You know that feeling when you look out at your backyard at night and think, it could use a little more life? Maybe you've seen those videos of people with beautiful flowing water and glowing lights, and you thought that would be amazing. But then reality hits. Most of those setups need a natural stream or river. And if you're like me, living in a regular house with a regular yard, you don't have that. So I started wondering, what if I could create my own little water system? One that keeps the water moving on its own, spins a small turbine,
the energy flow is established, initiating the activation sequence.
That's exactly
As the
what
turbine
I decided
spins
to
up,
try.
the system is
I
fully
wanted to build a
engaged.
recirculating water generator, something that doesn't rely on nature giving me a stream. Just a simple loop of water that I control, a small turbine, and some basic electronics. The goal wasn't to power my whole house or go completely off-grid. I just wanted to see if I could make something that looks good, sounds relaxing, and gives me a little bit of free power in the process. Now, I'll be honest with you from the beginning, this isn't some miracle-free energy device. The power output is small. But what surprised me was how satisfying it felt once everything started working.
Here we can see the mechanism in slow motion.
You
The
don't need a
kinetic
river,
energy of the water
a hill,
spins the
or
turbine,
even a big
resulting in
yard
a
to try
measurable
something like
energy
this.
output.
In this video, I'm going to show you exactly how I built it, step by step. I'll share what worked, what didn't, the mistakes I made along the way,
First,
and how the system
identify the
actually
leak in the
performs at
PVC
night
joint.
when the lights come on.
Use the
If
specialized
you've ever
wrench
wanted
to
to add a
loosen the
little
connection,
movement and light
then
to your
apply the
backyard
waterproof
without running more extension cords or increasing your electricity bill, then stick around. Because even if you don't have a natural water source, you might still be able to make something pretty special. Let me show you how it all came together. Chung tu fin barn da chin shur, chi teet kike lam, plus eat ki twut. Once I had a rough idea in mind, I started gathering the parts. I wanted to keep this project simple and not too expensive, so I focused on things that were easy to find and relatively cheap. The main components I used were a small submersible fountain pump, around 510 watts. This would be the heart of the system. It pushes the water through the loop. Some 1-inch and 3/4-inch PVC pipes and elbows to create the channel. A small DC motor that I would use as a generator. A basic voltage regulator module and a small rechargeable battery, like a power bank or 18650 cells. Some clear tubing, hose clamps, and waterproof silicone sealant. I chose a submersible pump because it's designed to work underwater and can run continuously without overheating too quickly. For the turbine, I picked a small DC motor because when you spin the shaft, it generates a small voltage. The faster it spins, the more voltage you get. That's basically how I would turn flowing water into electricity. After getting the parts, I moved on to building the water channel. This was the most important part because the whole system depends on having a steady, controlled flow of water. I decided to build a shallow, curved channel that starts higher and gently slopes downward. The pump sits at the lowest point in a small reservoir. I used a plastic storage bin hidden with rocks. When the pump turns on, it pushes water up through a pipe to the highest point of the channel. From there, gravity pulls the water down the slope, past the turbine, and back into the reservoir. This creates a continuous loop. I started by laying
Ensure
out
the blade is
path on the
aligned
ground
with your
with
mark.
a garden hose
Apply
to
firm,
visualize
steady
the shape.
pressure, and the ratcheting
Then I
mechanism
cut the
does the work,
PVC pipes
resulting in a
accordingly.
perfectly smooth
The
edge.
key here was getting the slope right. If the slope is too steep, water rushes down too fast, and the turbine spins wildly and becomes unstable. If it's too flat, the water barely moves, and there's not enough force to turn the turbine properly. I aimed for a gentle, consistent slope, roughly a 5 to 8 degree drop over the length of the channel. This gave the water enough speed to spin the turbine without being too
Start
aggressive.
by applying a liberal
Connecting
coat
the
of purple
pipes was
primer to the
straightforward,
pipe and
but
the fitting.
required patience.
Next,
I used
apply the
PVC
clear
primer
PVC
and
cement.
for the permanent joints, and hose clamps with rubber gaskets for the places I might need to adjust later. The most time-consuming part was sealing everything properly. I applied silicone sealant generously around every connection that would be underwater or exposed to splashing. Even small leaks can reduce water pressure and make the system less efficient. Once the channel was built, I installed the turbine. I mounted the DC motor on a small wooden or plastic platform above the water, so only the propeller or impeller I attached to the shaft sat in the flowing water. The idea is simple. Moving water hits the blades, spins the shaft, and the motor generates electricity. At this stage, I also added a small ball valve on the outlet side of the pump. This was important because it
By
let me
turning the
control
handle
the flow
clockwise,
rate.
we
By
restrict
slightly
the flow.
closing the valve,
You can see the
I could
valve is
reduce
now
the water
50%
speed,
closed,
which helped
significantly
fine-tune how
reducing the
fast
water
the turbine
speed.
spun. Without this valve, the flow was either too strong or too weak. After everything was connected, I filled the reservoir with water and turned on the pump for the first time. There were a few leaks here and there, so I had to go back and add more sealant and tighten the clamps. It took about 3 or 4 tries before the loop was completely watertight and the water flowed smoothly from the top of the channel all the way back down. Seeing the water actually circulating in a closed loop for the first time felt really good. It wasn't generating electricity yet, but the mechanical foundation was finally working the way I hoped. After the water channel was working properly, it was time to connect the electrical side. This was the part I was most nervous about, because I would be dealing with electricity and water at the same time. The setup was fairly simple in theory. The DC motor I was using as a generator would produce a small voltage when the turbine spun. That voltage would go through a voltage regulator module to
The glowing yellow
stabilize
pulse
it,
traces
then
through
charge
the
a small
regulator
battery.
board,
From the
optimizing
battery,
the charge.
I connected a few
It
LED
flows into the
garden
battery,
lights.
and
I
then
started by mounting the voltage regulator and battery in a small waterproof plastic box. This was important because I didn't want any electronics getting wet.
Carefully align the
I drilled
drill bit
small
and
holes
bore
for
through the
wires
plastic
and
box.
sealed them carefully with
Now,
silicone and heat
insert
shrink
the red
tubing.
cable through the opening.
Polarity mattered here. I had to make sure the positive and negative wires from the motor went to the correct terminals on the regulator. If I got it wrong, it could damage the components. Once the electronics box was ready, I ran the wires from the DC motor down to the box. I used
Ensure
outdoor-rated
the
wire
outdoor-rated
and made
cable
sure
is
all
flush against the
connections
wood.
were protected
Secure
from
the cable
moisture.
firmly with a
Then I
high-quality
connected the
zip
LED
tie,
lights
pulling it taut,
to the
and trim
battery
the
output.
excess cleanly.
I
Carefully
chose
insert the
low-power
stripped
LED
copper
lights
wires into the
because they
terminal
don't
block.
draw much current,
Use
which is
the
important when
screwdriver
your
to
power
tighten the
source
connection
is only a
firmly
small
until
turbine.
secured.
When everything was wired up, I was excited to do the first test. I filled the reservoir with water, turned on the pump, and waited to see what would happen. At first, nothing. The turbine was spinning, but very slowly. I checked the voltage with a multimeter, and it was barely registering anything, maybe 1 or 2 volts at most, not enough to charge the battery or light up the LEDs. I felt a bit disappointed. I had spent quite a bit of time building everything, and it looked like it wasn't going to work. I started troubleshooting. First, I checked if the turbine blades were actually catching enough water. They were, but the flow wasn't strong enough to spin the motor fast. Then I realized the issue might be with how I mounted the motor. The shaft wasn't perfectly aligned with the water flow, so some energy was being lost. I adjusted the angle of the motor slightly, so the water hit the blades more directly. That helped a little, but still not enough. After some trial and error, I discovered 2 main problems. First, the pump I was using wasn't powerful enough
As you can
to create
see,
strong
the weak
water
pump on the
pressure
left
over the
struggles,
distance of my
resulting in
channel.
inefficient flow.
Second, the DC
On the right,
motor I
high
chose
internal
had a
resistance.
relatively high internal resistance, meaning it needed to spin quite fast before it produced usable voltage. I decided to make 2 changes. I upgraded to a slightly stronger pump, still a submersible fountain pump, but with higher flow rate. I also swapped the motor for one with lower resistance that could generate voltage at slower speeds. These weren't expensive changes, but they made a noticeable difference. After installing the new pump and motor, I tested again. This time, the turbine spun much faster and more consistently. When I checked with the multimeter, I was getting around 5 to 7 volts under load, enough to start charging the small battery. After about 20 minutes, the battery had enough power to turn on the LED lights. Seeing those lights come on for the first time, even though they were dim at the beginning, felt really rewarding. It wasn't perfect yet, but it proved the concept actually worked. The system could generate and store a small amount of power from flowing water. Of course, there were still issues to solve, like making sure everything stayed waterproof during rain and optimizing the flow even more, but at least I had passed the biggest hurdle. The first real test had almost failed, but with some adjustments, it finally started working. After all the adjustments and troubleshooting, I finally reached the moment I had been waiting for, testing the system at night. I waited until it got dark, turned on the pump, and just stood there watching. The water started flowing through the channel, the turbine began spinning steadily, and after a few minutes, the LED lights slowly came on. It wasn't super bright like commercial garden lights, but it was a soft, warm glow that looked really nice against the darkness. The gentle sound of flowing water made the whole scene feel surprisingly peaceful. I let it run for about 2 hours that first night. During that time, the battery stayed charged enough to keep the lights on without dimming too much. I was honestly surprised at how well it worked once everything was tuned properly. The system wasn't producing a huge amount of power, probably around 3 to 5 watts on average, but it was consistent and enough to run several small LED lights for a few hours. Of course, there are clear limitations. This setup won't replace your regular outdoor lighting or power anything heavy. It's more of a decorative and experimental project. On cloudy days or if the pump is running at lower speed, the power output drops. And during heavy rain, I still need to be careful and sometimes cover parts of the electronics just to be safe. But even with those limitations, I found the whole experience really rewarding. There's something satisfying about seeing a small system you built yourself actually working, especially at night, when everything looks calm and a little magical. The combination of moving water and soft lights changed the feel of that corner of my yard completely. Looking back, here are a few things I learned from this project. First, getting the water flow right is more important than having expensive parts. Once I improved the pump and adjusted the slope and valve, everything became much more stable. Second, protecting the electronics from moisture is non-negotiable. Even small amounts of water getting into the connections can cause problems over time. Third, it's okay to start small and improve gradually. My first version didn't work well, but by making small changes step by step, I eventually got it running properly. If you're thinking about trying something similar, I'd suggest starting with the mechanical part first. Focus on getting a steady water flow before worrying too much about the electricity. Also, don't expect this to be a major source of free power. Think of it more as a fun backyard feature that happens to generate a little electricity on the side. For me, this project turned out better than I expected. It gave me a nice little feature in the garden, taught me a few practical things about small-scale hydropower, and most importantly, it was genuinely enjoyable to build and watch come to life. So that's the story of how I built a recirculating water generator in my backyard without needing a natural stream. It's not perfect, but it works, it looks good at night, and I'm pretty happy with how it turned out. Thanks for watching. If you end up building something like this yourself, I'd love to hear about it in the comments.